Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. In my previous video, I explained about all types of fire protection system which includes in civil defense. So now I am going to explain one by one for every fire protection system that how to design and how to size everything. So in this video I am going to explain about dry riser system. So in dry riser system, see, the dry riser system are normally dry without a permanent fire pump or water connection to it and depend on the civil defense fire truck to pump water into the system. It means that there is one dry riser. This is the riser pipe and connected all the landing valve. Each floor have landing valve connected in this riser, and this riser is connected to the breaching inlet for fire truck, and all this pipe is normally without water. Okay, when fire will happen, then fire truck will come and connect the hose with the breaching inlet and pump the water into the system. So how to decide the riser numbers and how to design this landing valve pipe size, we are going to see. Okay, so suppose in this video also I am going to explain how to drafting along with the how to design. So here it is AutoCAD. I open AutoCAD for drafting, and suppose before this I want to explain. See, this is the building. See, this is the building. Suppose this building is up to the third floor. Okay, one basement and first, second, third floor with roof. Okay, so this building have suppose two riser. One riser is along with this staircase, other riser is along with this staircase. Okay, one landing valve is here, other landing valve is here. Okay, and this building is third floor. Okay, third floor. So here suppose I make one layer for level. Okay, and this level I make like this dash line type. Okay, and set to current layer. This is the ground level. Or I make this one array. Each floor have 3 meter. Firstly I have to check, yes, it's millimeter. Minus 3 millimeter. Three meter each floor. Okay, and I'm going to rename this one text. This is the ground floor. Large text only. Ground floor, first floor, second floor, third floor, and the roof. Okay. Little bit hanging. See, this is first floor, this is second floor, this is third floor, and this is the roof. For dry rise system we use only medium rise building, not in high rise building. In high rise building we use wet fire protection system, so we will see in further session. Okay, because if we will use dry rise system in high rise building, then the civil defense truck is not capable to pump the water in that high riser system. Okay, because in high rise building normally consider the building which height is more than 23 meter, so the fire truck pump is not capable to pump the water at that much height. Okay, so this dry riser system we use only in medium rise building up to third floor or fifth floor. That's it. Okay, so suppose this is any building which consists ground floor, first floor, second floor, and third floor. We have to design dry riser system. Okay, so each floor have 2 landing wall. Okay, we consider that this floor, it means all floor of this building is more than their zone limitation. Okay, so we simply cannot take one riser, two riser or three riser. We simply cannot take one riser, two riser, three riser. No, it's depend on the zone limitation. Okay, zone limitation. So suppose this building comes under light hazards, okay, or any hazards. We will see here. Zone limitation. Low zone fire hose. Suppose generally if this building comes under light hazards, then their zone limitation is 52,000 square feet. If this floor or any of the floor is exceeding more than 52,000 feet square, then we consider another riser. Okay, so and in ordinary hazards same, but in extra hazard it comes 40,000 square feet. If we are going to design an extra hazard system and that floor exceed more than 40,000 feet square, then we take another riser. Otherwise, if floor is less than 52,000 feet square and it comes under light hazards, then we consider only one riser. So suppose we are considering this is light hazards. How to decide hazards? If you have not watched my hazards video, then kindly go and watch that video so that it will be clear about the hazards. Okay, so here suppose this building and this floor is exceeding more than 52,000 feet square. Okay, so we have to take two riser. Okay, so here we make one layer extra for pipe. We change the line type. Delete this one and make a new layer. Pipe continuous. Color we take red, make this one. So here I am considering that it is two riser. Two riser. Each floor have two landing wall because this floor is exceeding 52,000 square feet. Okay, and this breaching inlet should be, as per the code, should be more than 457 mm and less than 1200. Here we see breaching inlet connection. Here here see, not less than 457 millimeter nor more than 1290 millimeter above the finished ground level. Okay, so this height should not be more than 1219. Here we have to set the dimension as a period. Okay. Yes, it's good because it's a comes under 457 mm to 1219. Between these we can take the breaching inlet from the ground floor. Okay, so it's a good height. Okay, and the landing valve should be from finished floor level to the landing valve height, from the finished floor level to the landing valve. Suppose we are placing the landing valve here, installing, so this height should not be less than 900 and more than 1200. Okay, so I am taking 1000 from the finished floor level. Okay, here 994. Okay, it's good. Or we can take simply 1000, 1 meter from the finished floor level, 1000. That copy this one. The roof no need. Okay, and also the breaching inlet floor no need the landing valve as per the NFPA code. Okay, so we already placed the pipe of the breaching inlet should be not less than 457 millimeter and not more than 1219 millimeter. So already we placed this one breaching inlet from the ground floor level, and also as per the NFPA the landing valve should not be less than 900 millimeter and more than 1200 millimeter. Okay, so already we place as per the NFPA. Okay, so now we have to size the pipe. Okay, so for sizing the pipe, breaching inlet connection, and for sizing for pipe size here, for pipe size, see, for pipe size this one. For dry riser system only. For wet riser system we do hydraulic calculation, which we will see in further session. But for dry riser system, the minimum pipe size for serving a single landing valve should be 65 mm diameter. Okay, and more than two or more than 2, the riser should be 100 millimeter diameter. It means the less 4 inch, it should be 4 inch, and 6 inch it's normally we take, but not less than 4 inch, it means 100 millimeter. Okay, so this riser serving more than 2, so this one should be 4 inch, 100 mm. Okay, and this one should be also 4 inch diameter, and this one pipe serving more than 2 landing valve. You know, landing valve, it means here is the landing valve. This is the landing valve I am talking about. This is the landing valve. Okay, if it is connected only one in the pipe, that pipe should be 65 millimeter diameter. Okay, but more than, if it's connected in the pipe 1 or more than 2, then pipe diameter, that riser should be not less than 4 inch. Okay, so this riser we already size that it should be 4 inch, it should be 4 inch, it should be 4 inch. Okay, but now I am going to drafting. Suppose this is the ground floor, we take from the, make it parental layer, and suppose this is the ground floor, and we take this one high ceiling and here we connect. Okay, this is the we take already from the high ceiling. Okay, now I am going to drafting this one. So this is the auto fluid for drafting. If you don't know about auto fluid, how to install, how to download, and how to use, then kindly comment. I will explain everything in other video. Okay, so here I'm going to drafting. This is the 4-inch. This is the 4-inch. Okay, and up to the here roof. Okay, this polyline we delete, this one we delete, this one we delete. Again we take the cold water, and also this pipe should be 4-inch because it's serving more than 2 landing valve. Okay, it's serving more than 2 landing valves, so it size should be 4-inch. For branch, it should be a branch like this branch, this one and this one. Let's make a perfect branch. This one also. And for each landing valve, pipe should be 65 mm diameter. Okay, so here we take, and with landing valve, so I don't have any landing valve block, so I use the gate valve. It should be side. Okay, it's look like good. For ortho on, just simply press the shift key in the keyboard, not always go here and press that one. Ortho mode. Okay, so this is the landing valve. The pipe size should be 65 mm, and for branch, this type of branch we take. Okay, perfect. For also same for steel pipe, for 65 mm it should be, and the landing valve here pipe and with landing valve use it, and side also, and we make press the shift key for ortho mode on. Okay, also we can take this one and copy each floor. Here, 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 and here. Okay, because okay, so we delete the polyline, single line, and make it branch. Okay, from this one and this one, let's make a branch. and this one make it branch. Also press enter, and if you want to take the same command, then press simply a space bar or enter, it will come the same command. Okay, no need to type every time branch. Okay, so we make perfect here branch, and each landing valve is 65 mm diameter, and the main riser should be 4 inch. So here also we make that one valve. Here the flange collar, it should be 4 inch flange collar for breaching inlet. Okay, for this is the breaching inlet, 2-way breaching inlet or 3-way breaching inlet. Okay, we make this one for outside. Okay, this breaching inlet should be not more than 18 meter. Suppose this is the breaching inlet, so the fire truck parking, suppose here is the parking, so from the parking and to the breaching inlet should not be more than 18 meter as per the NFPA. Okay, as per the NFPA, if this parking is more than 18 meter, then this breaching inlet should be inside the 18 meter. We can take the pipe, so that the parking and the breaching inlet distance should be maintained under 18 meter. Okay, now it's clear. And for this one we take here for controlling gate valve and air release valve, air relief valve or release valve, because if they will pump the water, then air can be trapped inside, so water will not be flow as fast. So we use here air vent. Okay, air vent. Here we use gate valve for controlling. We make it side, press the shift key from the keyboard, and also we use the relief valve. Okay, no problem. Here we use no. We use this one, gate valve and air release valve. For this one, okay, suppose cut this one simply and make the pipe here, increase the pipe and reduce. Okay, modify and make it 1 inch for air release valve. No need to use 4 inch. Okay, this type of concentric or eccentric. Yes, concentric. It should be 450. Okay, here, and make valving for relief valve. Okay, tab, we make this one. Here we make gate valve for controlling and air relief valve at the top side. And for checking the pressure, we simply connect here one pressure gauge. Okay, so these three things we need in this the riser for checking the pressure, one pressure gauge, and for controlling one gate valve, and for relief the air inside we take this one air relief valve. That's it. Okay, same thing here we need. Here we use gate valve, we can use gate valve side. Okay, no problem, press the shift key here, and okay, and for pipe we use here, modify the diameter 1 inch. Okay, this type of, and we use valving for relief valve. Okay, use a relief valve, and for gate valve and for measuring the pressure we use the pressure gauge. Okay, here two things. So now we size the perfect. Now for texting we use this one. For text we use, so this one is the dry riser pipe. Okay, and this is the high level above the ceiling. Yes, below the ceiling and above the fall ceiling we take this one, and also pipe size we take. Okay, we take simply like this. And for sizing, and we take this one like this. This is the 100 mm and dry riser pipe, high level ceiling. Okay, the level is high. Also we take this one, we size this one for riser or dry riser pipe. Okay, size the pipe, and same we copy and place here. Okay, and for landing valve here we landing valve. Yes, this is the landing valve. Okay, and this one is the air release valve. Air ARV, air relief valve. And pressure gauge. Pressure gauge. This is the pressure gauge. Okay. So this one is the perfect. Okay. This is the breaching inlet. Breaching inlet. Okay. So this is the breaching inlet. This we size the perfect according to the NFPA, their branch, and the landing valve. Also, I should mention here the pipe size. Each landing valve pipe size is 65, not less than 65 mm each landing valve. Okay, so this is the landing valve and their pipes should be 65 mm. So we size as per the NFPA. This hose system comes under the class 1 system. So I want to explain something about the class of the hose. Generally an interview asks that what is the class of fire hose cabinet. Okay, so the class of fire hose cabinet is class 1, 2 and 3. This is the class 1, class 2 and class 3. In class 1 we size already 65 mm diameter, it should be the pipe, and 30 meter long the hose, it should be with the landing valve. So during fire we connect the hose in the landing valve and for the water. Okay, in class 1 landing valve the minimum pressure should be 6.9 bar. Okay, it means 100 psi. The minimum pressure should be 100 psi at the remotest landing valve. It means from the here the remotest landing valve is this one. Okay, so this landing valve here pressure should be 6.9 bar. If it's exceeding 6.9 bar pressure, then we have to use, or we must use, the pressure reducing valve if it's exceeding 7 bar. Okay, but the minimum pressure should be here required 100 psi, it means 6.9 bar. Okay, so this system is called dry riser system, and we use the landing valve comes under the class 1. Okay, it comes under the class 1. For class 2 is called fire hose or reel system. Fire hose or reel system. It means the reel, it means this is the fire rake. Okay, fire hose rake system. This is the rake. Okay, this is the rake and this is the hose, or this is the hose pipe. Okay, so it's called fire hose rake system. It comes under class 2. And for this one called fire hose reel, because it's connected, the reel is connected in the drum. So when we size this one, the pipe should be minimum 14 mm or 25 mm. Okay, we will see in further session how to size the fire hose reel system or rake system. Okay, so this fire hose rake and the reel comes under class 2 hose system. Okay, class 3 hose system, it's combined class 1 and 2. Okay, it means the landing valve with the fire hose cabinet or fire rack cabinet. Okay, here we don't have any photo, but it comes the combination of class 1 hose and class 2 hose systems called class 3 hose system. Okay, so in class 1 hose system, the remotest landing valve pressure should be 6.9 bar. Okay, 6.9 bar. If it exceeds 7 bar, then we must use the pressure relief valve or pressure reducing valve. Okay, in class 2 system, the pressure should be minimum 4.5 bar. Okay, it means 65 psi. The remotest fire hose or rake, the pressure should be at that hose system should be 4.5 bar. Okay, so we explained today about fire hose class 1, class 2, class 3, and the dry riser system. And the dry riser system, it comes under the water based fire protection system. Number 1, dry riser system we use in the medium rise building. Okay, so today we already saw this one, how to place the landing valve from the finished floor level up to the landing valve, what should be the distance, and the breaching inlet from the ground floor, what should be the height. Okay, what should be the height of the finished floor level and the landing valve each floor, and what we use at the top of the riser. Okay, we already see as per the NFPA 13. Okay, thank you very much. In next video we will see other fire protection system like weight riser system or any other system. Okay, first one we finish this one, landing valve. So if you learn something from this video, so kindly like, comment and share. Thank you very much.